Welcome back to video number 4 on optimization for UEFN or Fortnite Islands by GameDevMicah. Hit me up on Twitter, LinkedIn as Micah Berninghausen, and what else is there? Twitter? Oh yeah, I guess YouTube. Here we are. If you're on Discord, I'm Die Pepsi. No, I'm not. Yes, I am. I'm GameDevMicah on Discord as well. Alright, so now we're going to go ahead and get into props. This would be what we actually make the world up of. And I'm going to actually talk about the different types of props, the 3 main different types of props that can be used to create your environments. So right here you should be pretty familiar if you want to make a new blueprint. You'll be presented with this Pick Parent Class screen. There's 2 options here, building prop and building static mesh. Both of these are replicated. It says building, the first one, building prop, building piece that is interactive and standalone. That means that this building prop, you can break it, you can place it, it will replicate, you can move it. It's the most expensive thing you can do, besides for devices, is to use a building prop, because it's meant for full interactivity. The next one below that, the building static mesh, this is a building actor that has a replicated static mesh component. It also can be hit and show some different things. When you click on either of these 2 actors, when you create them, you're going to see a whole bunch of options on them for things like, play hit animation and things like that you do not need on your actor if you're representing a piece of static environment. So that's why what we'll talk about down here is my recommendation for your static, non-interactable environment to be made out of an actor class and then have components attached to it for what you want to render, be it a static mesh component or preferably an instant static mesh component, an ISM, which gets rendered in bulk on the GPU very efficiently. So you want to make sure that you're using a prop and you need it to do all the things that's on it. Otherwise, that's wasted space. Once the scene graph comes out and is production ready, that's going to basically be a more efficient way to render a static mesh than an actor plus a static mesh component, because the very class of actor itself is heavier than the new entity class that they're making items out of with the scene graph. So Unreal is directly looking to address this with the scene graph. So these things change once that comes out. But right now, an actor class, which would be down below this, just straight actor with attached components of either a static mesh component or an ISM, is the most efficient way to render your static environment. That will be superseded by entities and the scene graph system. So I'll just read through here. Building props are movable and replicated. This is the most expensive way to render a world asset and should be avoided unless that asset needs to be moved or destroyed. Building static meshes are not movable or damageable and so are less expensive or the least expensive way to render UEFN pre-baked meshes. That's what the when you drag out components in the screen, they'll be made of this. And they also are buildable on. So you can do things like make actor with a static mesh component, like I was talking about earlier, and then make it a subclass of the building static mesh so it can be built on. And that is cheaper than the default class as well. At least that's from this is a little bit, we get a little bit in the vagueness here, which is when you go to start building on the stuff, but not being able to, you can make a class cheap that you can't interact with, but will still be buildable on by making sure it's part of a what's it called? Oh, it's right here. Building static mesh. Subclass to the building static mesh, which is what is right up here. So this is what you need if you have to build on it. If there's no building in your game, then actor with static mesh or ISM is cheaper if you don't need building. If it's like a warm-up game without building or just a shooting game. Each UEFN prop asset is different. You must inspect to ensure your level and items are built with the cheapest possible component that still provides the full functionality you're looking for your game. So when you drag props out into the world, devices out into the world, like imagine if you were dragging a device out in the world, like a locker, just because you want a locker there. Not the device that vends things out to you, but just the visual of a locker. That would be extremely expensive because the locker itself has a whole bunch of other things like lights in it, sounds, verse coding that would be stored in memory. So in the less is best way, you have a bunch of stuff you're not using and then one image of a locker that you're using. The best thing to do there would be to get that locker and make it a custom mesh that's always rendered in the world, and then to pool the resources there only if you need to use them. And that's what device pooling is. But we won't talk about device pooling much because that's a verse stuff and a very high level thing to do, or very in-game optimization right now to do, but it's something you should look up if you're ready for it. So let's just go into some of the checkboxes that you'll commonly see on UEFN props and devices and talk about them. One of them is gravity. It's erroneous. Gravity was for when physics was involved in Fortnite. It was removed, so gravity, like CCD, are just not used. In the future, and I think soon we're going to get physics added back into Fortnite, then the gravity checkbox and the CCD checkbox will start to have an effect again. I like to leave the gravity and CCD unchecked because it's the right way to do it. You don't want gravity, you don't want CCD, so if it ever gets enabled in the future, they won't have it enabled on them. Mesh distance fields. This is a big one. If you don't need shadows or soft shadows or particle collisions, if you're using any of that, then disabling mesh distance field generation on meshes will make it run faster. Why? Every mesh has to generate a mesh distance field. This is a representation of it for the engine's lighting and particle impacts. That generation takes time every frame. It does get cached, but as you stream around or move around the world, that mesh distance field representation follows you, and so it's grabbing new meshes and regenerating them as well and adding it in. So if you opt out of mesh distance fields and it looks art directionally the same and acts the same, it will run faster without mesh distance field enabled on those different devices and objects. So that's what mesh distance fields are. And I will show down below in this document, maybe in a future video, depending on where it falls every 20 minutes, how those mesh distance fields looked, what the impact is, and all that stuff. That's covered in here. Collisions. Collisions are costly, like shadows. So I'll actually read this. Collisions. No collision preset. Like shadows, collisions are calculated per channel. They're enabled, overlapped, and block. The less your collisions block or overlap other channels, the less work they will require the system to do each frame. Reduction of collisions increase frame rate, but does not affect package or memory cost much at all. Setting no collisions on a mesh can help remove that actor from consideration and increase frame rates the most versus any type of collisions still being enabled. So if you can never touch an object, like think about a book up on a shelf in a room. If the player can't jump up to that shelf, can't bump into those objects, turning collisions off is more efficient because then the system doesn't have to see if it needs to stop the player from colliding with those books. Same things for shadows. Those books, if the shadow cast in the room would be on the shelf and maybe the player can never see on that shelf, just see the books, turning off shadows is going to lighten up the load from the system having to cast shadows for those books. And that just goes into everything. Anything you can't or don't use for an actor or device or can't use because it's out of the way, turning off that calculation saves you. Same thing for hit and overlap events generation. You'll see on an object that it could generate hits or generate overlaps. If you're not doing anything with the object, you don't need it to generate hits. You don't need it to generate overlaps. By turning those off, the system won't compute that stuff. All right, let's move into custom static mesh rendering methods. On all platforms, less triangles, less data is best. The more powerful the platform, less any single issue will have on a major impact. But combined, the data and density will always drive slower performance versus less dense detail. Less is best. Static mesh components are what render images on the screen one at a time. You can also use instant static mesh components, which we'll talk about next, but let's talk about static mesh components. They require the CPU to assess them because they are each individual. A draw call for each one and a draw call for each material. When you have multiple meshes, such as LODs for a mesh, those are also drawn, included in memory, and cost you. So if you have, say, 5 different levels of detail for one mesh, you would have 5 meshes for that mesh. You have perhaps 5 different textures or materials used as well, depending on what's been assigned, you could. And so you have that all loaded into memory. So it will be a much larger memory footprint versus if you have just one of those meshes and one of those materials. But rendering and frame rate is what we're talking about here. When you as well. So your package size with 5 LODs will increase. Your memory size will increase, but you might render faster or have more frame rate because you have LODs, because once that item is far away from the camera, it could be showing less polygons and a cheaper material from your selection, and hence operate faster in the frame rate, even though it has a heavier memory footprint, and so act smoother. When you have a whole bunch of these meshes, you may not be able to fit it all in the memory, and so then that's when the smoothness will go away because you'll have everything jam-packed with a whole bunch of versions, and that's what you have to address. So a static mesh is the heaviest way to render a mesh because you only render it once, and each one has to be assessed. So if you have the same mesh out there 5 times with 5 actors, 5 static mesh components, it will be 5 draw calls plus the textures for each one, so probably 10 or 20 draw calls. If you were to say move to those 5 static meshes into an instant static mesh component, instant static mesh components require CPU assessment for the component itself and its bounds, but there would just be one component instead of 5 to be assessed by the CPU, and then it gets sent to the GPU for culling and assessment rather than doing culling on the CPU as a single static mesh would. So you get GPU speeds out of ISMs when using multiple instances rather than CPU speeds by using static meshes. And the GPU is 100 to 1,000 times faster at doing these type of processes than the CPU is. ISMs are getting levels of detail in Unreal Engine 5.5. This is kind of written, but they're not exposed yet. So things are changing in ISMs, most likely so that the ISM component will replace the HISM below. What is an HISM? It's a collection of ISMs like LODs for static meshes, straight up. So these will load 5 meshes, 5 textures, just like a static mesh would, but will instance or do hundreds of them for the same cost, so it's more efficient. So static mesh components are the most costly because you don't get any of the GPU assessment, none of the batching. Instant static meshes are better, but they won't allow any type of level of detail, where the level of detail would help reduce polys and materials by streaming in for visual or rendering those less amount of details. Where which is something you can do in HISMs, is have level of details. The ISM is just going to be a single mesh, so it's lighter, but it won't dither. If you're using nanite, which UEFN, you can't bet that everyone's going to be using nanite, so you're going to be stuck with HLODs, or if you do use nanite, the level of detail will be taken care of by nanite. But ISMs will also very efficiently render high detail meshes and don't need to have LODs on. But the overall poly count and the low-end devices out there mean that you can't really count on that on everywhere. So it's best to use at least GPU components, the ISMs and HISMs, to get this GPU culling, GPU batch rendering versus static meshes. Most every island I've dealt with is completely built with individual static mesh components. Very few, if any, have even heard of ISMs, and they have or when they do, they have extremely good definitions on why they don't want to use them, which is that reference to the memory thermometer maybe not showing up or being too good, and maybe having their island kicked out in 6 months when Epic starts to add this in. We don't know. But performance-wise, ISMs and HISMs are much more performant, and they also seem to be showing less memory impacts. Both ISM and HISMs provide occlusion culling on the GPU and distance culling. These are keys for rendering, but addressed on the GPU instead of the CPU like a static mesh would. Unreal Engine 5, and actually 4.202, added something called automatic dynamic batching for rendering. This will go through and each frame scrape the world for static meshes to add them into an ISM only for rendering. It doesn't get rid of the actors themselves. This is purely a rendering thing. When you go and convert or build your world with ISMs or HISMs, you cut out that work of the system having to figure out if the static mesh can be rendered and all that. So it's quicker when you use ISMs yourself. But I did want to just mention that that ISMs are so well used and so important to Unreal that they use them underneath the covers every frame to harmonize and scrape the system into ISMs themselves. We are gaining the additional advantage of removing actor count by doing ISM work ourselves too. And this one is at 16 minutes. We're going to finish this page, and then we'll go into the next pages on the next video. Custom stack mesh optimizations. Less is more. The smaller your asset size on disk, the less vertices and triangles it has, the faster it will render in all conditions. Nanite is wonderful, but can only be supported on some platforms. It still sends an amount of triangles to the GPU. Reduction in the amount of triangles sent to the GPU will result in faster rendering and less triangles. Reduce your meshes even when they're using Nanite, and especially when they're not using Nanite. You can use the wireframe view and the Nanite triangle viewport filters to visualize triangle density and look and see what assets you want to reduce. So if you have your level out there, you can just turn on wireframe mode or turn on Nanite mode and see where there's the most amount of triangles and go to that mesh, use a different mesh, or try and reduce the detail on that mesh. I think we do one more page over on 12. Custom mesh reduction. Oh, this is talking about how to reduce meshes on your custom assets. There's when you open up your mesh, so go find your mesh, open up the mesh editor, and you'll have some options on importing and Nanite settings. You can turn these down from 100% to like 9% or 10% and see if it still visually looks like the type of stuff you want. By doing so, you can reduce vertices to wherever it looks good. And you want to reduce your fallback percentages too. And here you see we're going from like 200 verts to 70 verts, going from 3K to 2K. You know, just these reduction rates here will all add up to that package size, include and add up to your memory thermometer. If you don't need collisions on this mesh, removing the collision primitive will reduce the size on disk of the asset as well. If you don't need mesh distance fields enabled on this mesh, so you never use it in that way, disabling mesh distance fields on it, mesh distance fields is more data that it's having to store too. So this is just lightening up those assets that you're using to create your world, getting rid of anything you're not actually using. Lighting. This is a big section. So we'll cover lighting in the next video. So we'll just cover the reduction here. All right. See you in a moment.